Hi, I'm David Glenn with Precision Air Company. I'm the service manager, and this is the second video in our series on thermostat wiring training. This particular video is focused on two-stage equipment, furnaces, heat pumps, air conditioners, and how we do the wiring connections. Our training objectives today, we're going to start with multi-stage or two-stage furnace wiring. And we're going to also take a look at the dip switches and the role that they play on Rheem equipment for high efficiency multi-stage systems. We're also going to take a look at multi-stage air conditioners, though we don't do that quite as often. Then more importantly, we are going to be working on how to wire up multi-stage heat pumps and the heat kits. Okay, so we're going to start off with multi-stage gas furnaces, primarily our 96% two-stage Rheem gas furnace. Now the wiring, this is an actual cutout diagram from the installation schematic. So when you're doing the installation and you're looking at the manual, you'll see a very similar, this is a segment of a larger diagram, but this is made simple. First off, when you're doing the thermostat, presuming that we are going to control this from the thermostat, you're going to need at least 6 wires if they have an air conditioner attached to the system, which is most often the case. And it assumes, of course, that you need to have the common wire used on the thermostat. Now, red is, this goes back to our previous video about the HVAC industry standards for what color wire goes where. There's only a few of the wires out of the bunch that really are a standard. After that, it kind of varies. But red is one of them. The red wire goes on the R terminal, which is your 24 volts to the system. Then you have your compressor call for cooling, assuming it's just an AC, and that is going to go on your Y terminal. The yellow wire goes on the Y terminal. Your green wire is going to go on the G terminal, which is your fan on call. That doesn't necessarily mean that the thermostat is controlling the fan when you call for heat or cooling. A lot of the times the equipment handles that. However, with thermostats, with air conditioners, the thermostat sometimes does control the actual fan call, because the compressor call on the Y terminal doesn't always have to go directly to the air handler. It can bypass it technically and go straight to the air conditioner. However, it's always best to tie all the equipment together and have a leg going from the thermostat to the furnace Y terminal on the control board, and then having it branch from there to the AC, so everything is getting the same communication. Now, our blue wire, if there's a blue wire available, it will be used for the common leg. And once again, I understand that Rheem is brown and other brands might have a different color inside the actual equipment. However, the wiring in between the equipment and at the thermostat, common is your blue wire. On a gas furnace, the white wire is used for a heating call, so you'll place it on W. And this is a stage 1 heating call. Now, depending on what wire is available to you, presuming that you do in fact have those 6 wires, and commonly it's going to be brown, or it actually might be black. It doesn't matter what you use, because after the primary red, blue, green, and yellow, and white, any other colors can be used as you see fit. So there's no standard past that point. So if you have a black wire or a brown wire, in this case I colored it brown, but it's probably going to be black if you just have enough wires to get the job done. If you have 6 wires going to the thermostat, you probably actually have 8. So you're probably going to have a couple of extra wires in there. Now, not all systems have it. Some customers want a 2-stage high efficiency furnace, but they do not have 6 wires. In fact, they only have 5 wires, but they also need the common. So there is a solution to this with particularly with the Rheem two-stage gas furnace. However, other brands generally have the same option also, and this is controlling it with dip switches at the control board. Open up the manual, which is occurring on every install, so you can review it and go through and check the dip switches to set them for the system and the home that you're putting the equipment in. Not every home is going to be the same, but all of the furnaces are coming with a default setting that is rarely ideally suited for this particular home that you're putting the system in. But if you don't have that extra wire, there are dip switches in here that will allow the control board of the furnace to dictate when second stage heating should come on. Now, second stage heating, just so we understand, it's a reduction in the inducer draft motor rate of operation and the fire rate of the furnace. So everything kind of steps down with the gas valve, inducer draft motor. Now the blower will often step down to a lower fan speed also. When you go to second stage, everything amps up into a higher operational level, so it's getting more BTUs into the system. Now, the dip switches that you're going to find in the manual, this is an actual outtake from the installation manual when you open it up and you take a look at it. Right off the bat, you need to be paying attention to what the timing is. So if you have the extra wire for second stage at the thermostat, you're going to leave it in the off-off position, which is what it's set for from the factory typically. Now, our company, we prefer to put it at 10 minutes if for the upstage to second stage. If they don't have that wire at the thermostat to dictate it themselves or let the thermostat decide when it should do it, then we usually put it at 10 minutes. So the furnace runs for 10 minutes in first stage, then it steps up to after 10 minutes to the second stage. Now, that's not the only thing you need to be paying attention to. This isn't even the only dip switch board in the furnace. There are others. You need to look at the configuration of the furnace that you're putting in. Now, when it comes from the factory, it's defaulted in the upflow position with the switch off. We put a lot of furnaces in that are in the downflow position, so you need to make sure you're configuring it for downflow. Now, this will adjust the blower settings a little bit when it's in the downflow, so it knows that it needs to run a little longer, but that can be controlled also. So you have not only dip switches for the rate of airflow based on the CFM requirements for cooling or the CFM requirements for heating based on the size of the system. So there's the furnaces, you need to set the CFM for what you are installing, and you've got to take into consideration the AC outside. If in downflow, it's not uncommon where the furnace shuts off, because in default it's got a 30-second delay. Heating shuts off, and then 30 seconds later the blower shuts down. But in a downflow, I'm sorry, 90 seconds. But in a cooling has a 30-second delay. But in a downflow configuration, there's a thermal limit that can open in the blower compartment when everything shuts off, but it didn't run the blower long enough, so the heat's rising from the secondary and the primary heat exchanger, causing that heat to rise up, trip the limit, and then the system can cycle off and they won't be able to turn it back on right away. Now, typically that's a self-resetting limit inside the Rheem, but some systems actually have a resettable pop switch that if this were to happen with, this is different brands, but if that ends up happening, you have to actually get into the blower compartment and reset that dip switch. For service technicians, while I'm on that note, pay attention. You're out on a diagnostic or you're doing a tune-up on a gas furnace and you have the panel door off. You test the system with a jumper, you fire up the furnace, you check everything, see how the flames are looking, see how everything's operating, checking amp draws, and then you're ready to do some cleaning and you just let go of the door switch and shut the system off right away. So the blower kicks off and the flames cut out, the inducer draft motor and the gas valve shut down. So what you didn't do in that scenario was allow the blower long enough to run for cooling off the heat exchanger, whether it's an 80% or high efficiency with a secondary heat exchanger. You need to let it run long enough to actually cool down the furnace before you remove power. And you can either A, take your jumper off, but if you controlled it from the thermostat, that doesn't mean you have to run inside. Just shut off the gas valve. Reach over, close the gas valve. It's going to go through a fault cycle, and then when it determines, it might even try to restart a couple of times. But eventually it'll just keep running the blower until it cools everything down. Then you can remove power. So the key message on this particular slide is read the manual when you're doing installation. If you're in the field, when you're doing a tune-up on a system, especially if it's a follow-up tune-up, say a year later or 6 months later on a system we had installed, technicians need to grab the manual, open it up, verify dip switches to make sure they're all set properly. So for multi-stage cooling, there's not a lot to go into here. This is the backplate for wiring connections on a Honeywell T6 that has second stage cooling capability. There's not too much to worry about here. With a two-stage cooling unit outside, which we don't put in as often up here in the Pacific Northwest as other people do in other regions, all you need is that extra wire to put on Y2. That's it. First stage cooling, when it's called for, is going to be in your yellow wire on the Y contact, and then an alternate wire that is not one of our primary HVAC industry standard colors is going to be on Y2. What's not acceptable is to wire Y and Y2 together out at the air conditioner so that when the system calls for cooling, it brings on both stages simultaneously. Now that is a technician temporary field fix when something's gone wrong and we need to do that. However, if it is a customer that has paid to have a two-stage cooling system put in, we need to give them that capability. They need to get their money's worth and the value that we're offering them. So make sure you have enough wires to perform that functionality. If it's somebody doing an estimate to sell a system, take a look. Are we going to have to run new thermostat wiring in order to achieve what the customer is asking for? If we've had even when you're going into furnaces that have only two wires because they've never had cooling before, you've got a problem with the number of wires, in which case we're looking at using a wireless RedLink system that's going to need an EIM board at the furnace and a secondary transformer to power that EIM board for wireless connectivity, in which case then they can have all the wires they need. They just need the two to provide the power at the thermostat itself, which is going to be your common and your power going up to the thermostat. And that's actually what the secondary transformer powers. It powers the thermostat by itself, or you can have it power the EIM board by itself. Usually I see it wired up for just the thermostat. But in this case, short slide, not a whole lot to go on. You just have to have a second wire for stage 2 cooling. That's it. That's all you need. So the very first thing we want to point out, when it comes to heat pumps with electric air handlers that have an electric backup heat kit, you do not put a wire on W at the thermostat. Don't use that. That is only for gas furnaces. Heating is created with a combination of your OB contact and your compressor call, which is on Y. Two-stage heating just requires a Y1 and a Y2 and a wire on OB. Now, we're not talking about the heat kit. We're just talking about the heat pump providing the first and second stage heating. So we're going to go through a tip. This is actually a schematic out of the Rheem installation manual. So we're going to discuss what we're running into. Now, this is practical and applies to nearly every system. The differences are the nomenclature that they use for different terminals or the coloring that they use on wiring inside the equipment. Our primary colors are still going to be our primary HVAC standard industry colors, but any extra wires that are needed beyond that can be used as you see fit. Now, the labeling of the coloring that is on this heat pump outdoor unit, it may not actually reflect the equipment that you're on. And the reason being is quite often the equipment itself, from generation to generation or model to model, may have different coloring guide, or the wires that are actually inside the heat pump may be different, not just from brand to brand, but within Rheem they can change up. Now, the more common thing that they like to do is they like to use the blue wire for the OB run, or in this case on Rheem, it's B, and they like to use brown for common. Yeah, regardless of those colors, you still use the industry standard connections. All right, so in this case, you see that we've got the red wire. So this is the R contact up here at the top for the thermostat. That's your 24-volt call, and it's going to go to R on both the heat pump and the air handler. And the air handler typically is also going to have a red wire. At the heat pump, it is also typically a red wire for that 24-volt connection. Now, common is blue, so you'll see a C on the thermostat, and you'll have on Rheem, it's a brown wire in the air handler and the heat pump. Different brands will use different colors. A lot of brands like to use the color blue inside the equipment for common also. So don't get locked in by colors. Colors, you want as much uniformity as you can, but when you get into the equipment, you cannot depend on the idea that this color means this. You always have to pull off the panel or find the paperwork or the manual, and you need to look at the ladder diagram or the schematics for that particular unit. If they're not available, you might have to trace things around to figure it out. Now, a lot of times, especially on heat pumps, you can figure that out fairly easily by just looking at the actual defrost control board. Our green wire goes for the fan call. There's no green wire use going out to the heat pump. There's no need for it. Orange. So, like I said, Rheem likes to use the blue wire for the OB contact. And just to recap what this means, most brands that are out there, the heat system of the heat pump, the reversing valve, sits in naturally a heating position. And when you get a 24-volt call on the OB contact from the thermostat, it's energizing that reversing valve to move into the cooling position, and that is called energizing on O. Rheem is naturally in a cooling position with the reversing valve. When you ask for heating, 24 volts is applied to the O wire, and that is going to energize the reversing valve into heating mode. Now it with your yellow wires. So at this point, we are now going to talk about the stage 1, stage 2. Your yellow wire is going to be on the Y contact, and it's going to be utilized for wiring up stage 1 and stage 2. Now, it should be labeled as Y1 or Y and Y2 on Rheem equipment. Some will say Y and Y1 and then Y2. So you just got to pay attention to how that particular model or brand is deciding to label the various stages of the equipment. However, you got to have enough wires for the multi-staging when the heat pump is operating under the control of the thermostat for deciding when stage 2 is. Sometimes it's the air handler that's deciding it, and sometimes it is your heat pump that may decide it. Every brand and between different models is different on how they want to control that. The more computerized it is, the more likely it is to be controlled by the heat pump itself. The thermostat often has deeper controls that allow you to dictate how things are going to work, especially on communicating systems. But in this case, I use purple. It doesn't necessarily mean you've got a purple wire. This schematic for this particular model of Rheem that I pulled the diagram from says that it's a yellow wire with a blue stripe for Y2, and that is fairly common. I've seen a yellow with a black stripe. I've seen, usually that's usually what you're going to see. So in this case, you have the yellow wire energized by the Y contact, which is your compressor call. So when they ask for heating, R routes power over to Y at the thermostat, and it's also simultaneously wiring or routing power to the B contact. So the reversing valve is energized to shift it over to heating mode at the heat pump, and your first stage compression is energized, and then whatever control is dictating when second stage compressor should engage, second stage heating engages with Y2 energized. Okay, so that was a discussion about the heat pump first and second stage. Now we're going to talk about multi-stage electric heat kits, or just wiring up the heat kits in general. And this does have more of a focus on Rheem particular equipment and how it's labeled. However, even the diagrams between multiple units and air handlers show different colored wiring depending on the generation or the model. So I'm not too focused on what the coloring of the wire is inside the equipment. You have to look at the ladder diagram and figure out what do they want the wire to mean inside the actual unit. Now, the electric heat kits are powered up by timed sequencers. If it's a 10 kW, it is likely only to have one stage of electric heat. And that's usually one sequencer that's got two stacks on it that are energized on a timing delay. So you'll see 20 kW heat kits will usually have two sequencers set up. And it'll also typically have two separate wires to energize those individual sequencers. And so you got to pay attention to that. We don't necessarily have to have the thermostat controlling the various sequencers, and most often we do not. Usually there's not enough wires anyhow, but more commonly we just allow the air handler and how we do our wiring setup to control that. The labels on the thermostat, that is ranged and varied. So on the Honeywell T6 thermostat, you'll see an E with an AUX. Now this schematic diagram that came out of the Rheem manual is showing EW1, and then it shows a W2. So once again, you're going to see different labels depending on who you're actually using for a brand of thermostat when you install it. Now, other terms that you might see on thermostats are W1, as you see in this one, EAUX, which is auxiliary. I hate saying that word. You might also see the word EMER for emergency spelled out, or just the letter E. I've seen some trains and older thermostats will often use the letter X to dictate emergency heat or the electric heat kit. Once again, you got to check the the ladder diagram for the equipment you're putting in, whether it's Goodman or if it's Rheem, whatever you're working with, focus on what they have their wire set up. Okay, so this is basically one stage of electric heat. The wire is going to be whatever color you use. You can use the white wire because it might be white. I would have colored this white, but you wouldn't be able to see it. So in this case, I made it purple, but you have that unused white wire, or you could use a black wire. Generally, you want to use, if you have a white and black wire, you typically would put white on your first stage, which is going to be your E, or it might say E-aux, EMER, X. Now be careful with the X, read the manual for that particular thermostat, because sometimes that might mean electric heat, or X might mean something entirely different. It might be a sensor contact or something. Now, the wiring for this, when you see this, you've got on the heat pump, Rheem has the letter D represented on the board for defrost. Your actual terminal label can vary from one brand to another. Not everybody calls it that. I see the letter L used sometimes. Either way, when defrost is called for, it needs a way to turn on the electric heat while it's defrosting, because defrost, in a sense, is just the heat pump shutting off the condenser fan motor and putting the system, it shifts the reversing valve into cooling mode. So now it's taking heat out of the home to the unit to help thaw it out because it's getting all frosty. And while it does that, it turns on electric heat to offset the cold air that it's generating. So you have multiple means of turning on the electrical heat. Now, the thermostat should have a functionality of isolating and selecting emergency heat in case something is wrong with the outdoor heat pump. The Nest can do it, but it's a little more complicated, and most of the time customers can't figure it out. So Nest is not always the most ideal thermostat with heat pump configurations. However, it is a functionality that's possible. With single stage, it's going to have a wire at the air handler that your thermostat wire coming off of the E is going to wire nut into. And then there's going to be a wire coming from the heat pump that you're going to also put in the same wire nut. They all just join together. Now, when you have second stage electrical heat, there's two ways that this can be done. The most uncommon way that it's done is, because there's usually not enough wires at the thermostat, is to actually put a wire in the W2 contact and run it down to the second wire in the air handler for the other sequencer kit. And now this particular schematic is showing that W1 and W2 are jumpered together, and that is the alternative. So with that one there, you have waiting for that to pop up. There we go. Put transitions in here, and I think I got the timings wrong. Normally, you don't have a wire going from W2 at the thermostat down to the air handler. Normally, all of it's going to be jumpered. Now, this actual jumper at the air handler is not always pre-built in. It is just your wire nut. So you have E wire coming from your thermostat going to the electric heat W1 contact, and you're going to wire nut that together with the wire coming from the heat pump. Well, you just take that extra wire that's in the air handler for the other sequencer and you wire it into the same wire nut. So essentially, when emergency heat comes on, it's not staging the heat kit, it's bringing it all on at once. And that is an optional functionality based on capability at the thermostat. And most often, we just wire it together so the heat kit all comes on at once. Okay, there's problems that you should be able to identify, and it's a good idea we identify it when we're doing our operational checkout of the system after installation. We need to run through these things, and when customers are the ones who find the problem, they usually experience it weeks or months after the installation was done. And if that happens, they could end up having an excessively large electric bill. So if you put a wire on W, then every time cooling comes on and every time heating is turned on, it's going to run the electric heat kit at the same time. So cooling is not going to be very effective, and heating is going to be super effective, but it's going to be very expensive. But because the electric heat kit comes on every time, their electric bill is going to skyrocket. It'll also cause excessive heat rise in the home, where they just kind of have this runaway heat where because of the way the sequencer timer is set up inside the air handler on particularly Rheem equipment, if you have a wire on W, it can force the electric heat kit, once energized, to now stay energized even after the system should have turned off. So what you end up with is a homeowner calling and saying, hey, it's 90 degrees in my house, the thermostat's set for 75, it's wrong. And we tell them to go cut the breaker if that's the case. We haven't really run into this, but that is a symptom of what you'd be looking at. So for service techs who are going out on a diagnostic, that's a clue that the wiring is going to be wrong, and first thing you want to take a look at is to find out if there's a wire on W. Especially if it's a homeowner who decided to put in their own thermostat. They always get that wrong. So check your wiring, operationally check each mode after an installation, get a multimeter and clamp onto the wires coming off of the, you can do it on the main harness for the leg coming in, run cooling, and then you're checking the amp draws. If you have a 20 kW air handler and you put it in cooling mode, and then a minute later you have 40 amps reading across the main line coming in, that tells you that the electric heat kit's probably coming on. Well, it is at that point. If you have a 10 kW, you'll probably see 20 amps across the board. So check that. Check it during heating mode when the electric heat kit should not be on and you've only increased the temperature by a couple of degrees. So heat should not have come on depending on how you set up the thermostat. And if you do see that high amperage draw, it might tell you that you got something wrong somewhere. All right, thank you for watching. If you have any other ideas for a training video or something that we need to cover, feel free to contact me and we can see what we can put together. Thank you.